Cool, so we're gonna get started looking at rotating triangle ABC by 90 degrees around point P. So if you take a look at our triangle, we got point P, 90 degrees. What makes a 90-degree angle other than our protractor, which in geometry land, we don't actually have this guy. It's just acting as a straight edge. So if we want to get a 90-degree angle, what we need to be able to do is construct something that has a 90-degree angle in it. And what has a 90-degree angle in it? A perpendicular bisector. So let's go ahead. I'm going to create the necessary conditions to get a perpendicular bisector. If I stretch my compass from P to C, now I'm going to go ahead over to the other side, and I'm going to just make a little mark like that. And now I know, let me call this Z for now, all right? Just to have a name for it, all right? But I know that Z and C, these guys are both equidistant or the same distance from point P. And so I have the conditions necessary to make myself a perpendicular bisector. So I'm going to stretch my compass out to over halfway, all right? And make some marks above and below P. So over halfway of CZ, all right, past P, all right? You can stretch it the whole way if you want. I'm just have to be over halfway. And when we bring the compass pin over to C and do the same thing, making marks above and below P, we wind up with the marks needed for our perpendicular bisector. So I'm going to go ahead and do that. All right, let's see. Bam. Bam, these are always the hardest ones because, you know, once you got it, you either got it or you don't. That looks pretty good. All right, great. So we know that this angle right here is a 90-degree angle. So let me just go ahead and write that in there. A little 90 degrees. All right, so we know that that guy is 90-degree angle. It's a right angle. And so if I were to take my compass and arc from point C down to where that guy crosses the perpendicular bisector, all right, I will now know exactly where C prime is. All right, so that C and this C prime, that's a 90-degree rotation if we're using P as that base of rotation, all right? And so we knew that C had to be somewhere on that arc, much like when we do reflections or translations, but we know exactly where it is because we're looking for a 90-degree rotation. So what I'm gonna do is I'm gonna create a bunch of other probability arcs, if you will, all right? What I mean by that is we know that there is point B somewhere on that arc, but we don't know where yet. But we have narrowed it down to one arc of space, and we know that A has to be on that arc somewhere, all right? So, hey, look, I already know where C prime is. Let's go back to the original triangles and look and see what we have already embedded in the triangle as far as information is. If I take my C, B, I take my pencil and stretch it C to B, just like that. And I'm gonna make sure it looks good because I wanna make sure it's perfect. There we go. Now if I go over to C prime and I arc somewhere on that B arc, well, that has to be where B prime is. Nice. So I've got C prime. I now know where B prime is. If I go and look and see what's the distance between C and A. Sorry, I know that you can't see this super well, but there we go. Hopefully you can see how that's the distance from C to A. Now if I go to C prime and I arc over onto that A arc, well, that has to be where A prime is going to be. And so just by applying some of the logic, right? A 90-degree angle formed by a perpendicular bisector, and then rotating one of the points by that 90 degrees, we can use the same ideas that we used for our translation, go back to the original triangle, and see what are the distances between each one of those points. And then use that information as a launching point from your C prime that you just discovered. So that's how we got to the A and the B. Hopefully that was useful.